Okay, so the topic for the day is a guide to Castin channels and anchors specifically for facade related applications. When we talk about facade, there are several challenges in fixing a facade element to a building structure. So, for facade installation, while we thought about it, we realized there are mainly a challenge which is related to easiness or ease of use, and at the same time the facade installation should be fast, because as we know facade comes at the later stage of a project, so relatively fast installation is preferable. Of course you need heavy loads because of buildings subjected to wind load, earthquake, temperature load, etc. So you need some fixing elements which are heavy duty, and also corrosion is at most important. This is also leading to safety of the building, so we want our fixings to be corrosion free so that they can stay for lifetime. And then also one main pain point what we realized from facade contractor interactions is most of the time while you try to fix a curtain wall bracket, while you drill the hole there is a clash with existing rebar which is heavily reinforced. You're not able to find the right spot, you change it, there is a lot of problems. So keeping these pain points in mind, we plan today's session. So commonly known fixing systems available internationally are two types. One system is called pre-installed system and the second one is called post-installed system. The difference is very clear. Pre-installed systems are installed before the concrete is cured. So basically it is installed before actually you pour concrete, and then post installed systems are installed after concrete installation is complete. The concrete has cured, it has reached certain capacity, so that is post installed systems. So pre installed system, an example is Fischer Castin channel. I would love to show a small sample how it looks like. I hope you can see my video. So you can see this is a sample of a Castin channel. So you can see this would be pre-installed inside concrete before you pour concrete, and then you pour over concrete and then the concrete cures and this gets locked inside the concrete. Perfect. Right. The second method, or the first method, in pre-installed systems, we have certain advantages. The advantages are the facade installation is pretty fast. You can quickly install these elements during the casting of a slab, as an example. And then after the slab is cured, of course, the facade comes after the slabs are ready. So when the facade is there, you just need to bolt it using some accessories. So it is very much easy and fast. It is heavy duty, it can take huge loads. It can resist corrosion because of the special coating applied on it. There is also no damaging of structural reinforcement bars inside concrete because you are keeping these cast-in channels before pouring of concrete, so you clearly know where rebars are there, reinforcement bars are present, so you can adjust your cast-in channels to avoid any clashes. The second system, the post-install system, you have mainly chemical anchors and mechanical anchors. In chemical anchors, we all know it is heavy duty and it can stand corrosion uh, subjected to the grade of material we carefully select. And then mechanical anchors are fast. You comparatively do not need to wait for a curing time. It is drill, insert, expand, and you can connect. It is relatively fast. And then you can also withstand corrosion again based on the quality or the type of metal which you choose, it should be adaptable to the environment. And the third type is the direct fastening option, which is like some sort of shooting arrangement using gas or powder actuated system. You shoot some fastening elements into the concrete. So this is extremely fast, but then you don't get it in heavy duty, or you cannot have multiple options, or uh, yeah. So the main advantage you have is it is fast. That's it. Now the definition of Castin channel, as per the code, it says that it is basically nothing but a steel profile which is rigidly connected to anchors installed prior to concreting. So as you can see on my screen, I hope, is a picture of a cast-in channel, which the channel itself is over here, and you can see it is connected rigidly to anchors. And then to call it a cast-in channel, we need to have at least two of these. And then this is not complete. Also, you need to have an arrangement. As an example, in this picture, you can see special T-bolts, which makes the system complete. So, and then your facade bracket can be bolted to these T-bolts. So, as I explained earlier, this is casted into the concrete before you pour concrete. It is kept in place before you pour concrete. And these are the components of a cast-in channel. So as I explained, you have an anchor, you have a channel, you have a connection point right here between the anchor and the channel. It could be welded, it could be bolted, it could be special bolted connections, riveted, and so on. And then you have channel lips. So the lip of the channel is where the T-bolts are getting connected, and this is the first point of contact where the loads are getting transferred. So also very important. Yes. And then last but not least is the channel bolt or the T-bolt, where we are able to connect a base plate or a facade bracket directly to the cast-in channel. Now, enough of talking. Let's watch a small video. I would request my technical team to play the video for us.
As the global market leader in anchor industry, Fischer has been piloting fixing technology by continuous improvement and providing the optimized innovative solution for building industries. Fischer cast-in channel systems have been granted ETA approval. The main compositions for Fischer cast-in channel includes one-time forming hot rolled or cold formed C-channel anchors and accessories. The material is using ETA recognized one, and surface can be treated with hot dip galvanized or zinc aluminum coating, which is seismic resistant, high strength, and corrosion resistant. In the applications of building facade, rail, and subway transportation, integrated pipeline tunnel, etc., Fischer cast-in channel systems have been more and more widely used, greatly improving the installation efficiency of post-installed fixing parts, reducing potential risks in on-site work and maintenance costs. In building facade application, Fischer cast-in channel systems are widely utilized in the installation and structural bearing of facade panels. Fischer cast-in channel can be connected to facade assembly through channel bolts to achieve an effective connection of the entire facade system. Position and install Fischer cast-in channel in the concrete formwork. Place the steel mesh and fix the cast-in channel via self-tapping screws. Fill the concrete evenly throughout the casting form and remove the formwork after the concrete is fully solidified. The filler in the channel is removed by a rip line. Insert the channel bolt and rotate 90 degrees following the grooved curve. Freely adjust the bolts to the proper position. Install the facade bracket and tighten the nut. Fix facade frames and other accessories, and then install the facade decoration panels. In this manner, the facade system construction is completed. In railway and subway transportation areas, Fischer cast-in channel systems are widely applied in subway tunnel and other curved structures. The subway tunnel is composed of several arc prefabricated concrete parts extending longitudinally to form the entire tunnel. Fischer cast-in channel systems can be customized to fit different building or structures based on their individual features. For example, Fischer curved cast-in channel system can fully fit the arc structure of the tunnel and reach ideal fixing effects. Due to the special arc structure of the tunnel, formwork used for pouring concrete is made of special steel framework. Fischer cast-in channel could be fixed to the steel formwork by special bolts and nuts. Then reinforcement is placed and the concrete is evenly filled into the entire framework. After the concrete is fully solidified, the formwork can be removed and the curved concrete panel is prefabricated. Remove the filler of the channel by rip line. Insert the channel bolt and rotate 90 degrees according to the grooved curve. Freely adjust the bolts to the proper position and finally install the matching system and equipment. Fischer cast-in channel systems can also be widely applied in integrated utility tunnels. It is mainly used for fixing Fischer Samontech systems. Integrated utility tunnels usually have rectangular structures in which main pipelines and ducts for civil infrastructural are laid. Fischer cast-in channel systems are used for the installation and carrying loads of these infrastructural pipelines and equipment and facilities to ensure normal operation. Position the cast-in channel in vertical formworks. After the reinforcement is placed, fix the cast-in channel in the framework. Then pour the concrete. Remove the framework after the concrete is solidified. Remove the filler in the channel by rip line. Insert the channel bolt and freely adjust the bolts to the proper position. Then install Fischer cantilever arm. A comprehensive product introduction and technical training can be provided so that customers can fully understand Fischer cast-in channel systems and related applications. Fischer technical team will provide professional calculation service based on different architectural design requirements. Concrete load-bearing capacity at different ambient environment, as well as fire-resistant, fatigue-resistant, and anti-corrosion will be fully considered to provide optimized fixing solution. Also, professional and complete on-site technical support service can be provided as well. During project execution phase, the whole process of tracking and guiding the installation and commissioning of the products will eliminate the customer's worries. Fischer has won wide recognition in the industry with its professional product technology and all-around high-quality service, and is starting a new journey of fixing solution with innovative ideas.
Welcome back. So I hope the video was clear. I'm sorry to hear that some of you had some issues with the sound and video, but I hope it was rectified. Okay, great. Any questions, any concerns you have in the video, please feel free to let me know. If not, we will continue with the presentation. Okay, now I have a question. What do you think, from your understanding, is the difference between hot rolled and cold formed? Thank you, Emil, for giving us your feedback. I repeat, any one of you can tell me the difference between hot rolled and cold formed. What do you think is the difference? I hope someone is typing. Yes, I can see some people are typing. Great. Okay, Mr. Adrian says how it is produced. Great. Emil says hot roll forms are ready products and cold forms are bended in shops from coils. Okay, extruded and pressurized. Okay. So great, guys. Thank you for actively participating in it. All of you are correct. So please keep on interacting, because otherwise it's an afternoon after lunch. It would be boring to sit in front of the laptop and just seeing your presentation. So please, I apologize if I'm asking too many questions, but this is just so that we can talk to each other and it is more interesting. So as you guys rightly explained, the difference between hot rolled and cold formed are in the way it is made. So in hot rolled, we have the process is made using higher temperature. So this is an example of a hot rolled channel. So the channel is made to this shape using higher temperature, and after the temperature, the material is molded to this particular shape, and thereby it increases its mechanical properties as well as eliminates any bubbles or cracks in the steel itself. So hot roll makes the material slightly or more stronger. And then coming to cold rolled or cold formed, as the name explained, this is a shape made while the metal is cold. So basically, we are making this channel by bending of steel sheets. So overall, cold formed will give a less capacity based on the way it is produced compared to a hot roll. So this is the main difference. And with me, I have some samples just to show you. So I want a reply. Is it a cold formed or it's a hot rolled? Is it a cold formed or a hot rolled? Okay, okay, excellent. So yes, this is a sample of a cold formed section, and this is a sample of a hot rolled section. So you can see the difference. Okay, perfect. So I hope that was clear. What are the benefits of using cast-in channel systems over conventional fixing methods like anchors or cast-in bolts, let's say? So first of all, the best advantage of using a cast-in channel system is the high level of prefabrication. Imagine you go to a building site and you can easily install your facade elements without any drilling or installing any anchors. Also, extreme application conditions, like imagine you have a tower which is having C80 grade of concrete and heavily reinforced, or imagine you have a very narrow or very shallow slab, 150 only, high strength concrete, very difficult to drill, no damage to existing structure. So even by mistake, we are not tampering any of the existing reinforcement which was designed for the building. Very important. And then simple and easy installation of channel bolt. So you only need a torque wrench to tighten the channel bolts, and that's it. So it's very fast, easy, and simple. Also, with the introduction of more and more building information modeling, uh, the building is becoming more informative. So we know exactly where you have reinforcement, where you have facade brackets. So it is easily to plan your cast-in channel installation much more better than it was 10 years back. Also, it is a concern of health and safety. Cast-in channel does not create much dust because of drilling of concrete. So it is much more easier, less use of drill machines. So again, you don't have any risk of damaging someone. This is a HSE concern. So there you have another advantage as well. Now it is noise, it is dust free, and your job site is much more cleaner. Typical applications for Castin channel, you have a wide range of applications starting from facade. You have elevator applications, you have MEP, mechanical, electrical, plumbing, you have power plants, you have a nuclear power plant or a hydroelectric power plant. You have a lot of equipments. If the concrete is really strong or you have heavy reinforcement, how bad it would be to drill a lot of holes. And also you have metro and rail. You might have seen from the video that when you have a curved tunnel, so how easily and seamlessly you can integrate a Castin channel directly to the building itself. And then when you have utility tunnels, like you have a tunnel for sewage water as an example, or a power transfer line, so it is very easily to embed these elements right into the building flush. So it is much more easier and convenient. Casting channels for facade. Since today's topic is about facade, I can think about mainly three cases or three scenarios where you would be using the casting channels. Number one, top of slab. Number two, front of slab or face of slab or on a wall. And then you have bottom of slab. So these are the three scenarios where you would require a casting channel. The benefits of Castin channel at a glance again is you don't require any drilling, no noise, no dust pollution, easy installation, you save time, no damage to existing reinforcement. You have 2D adjustability, so you cover certain side tolerances because you have two direction of adjustment, and you have surface flush disassembly possible. If in case you want to remove one of your curtain wall brackets, you can very well remove the assembly by just removing the T-bolts, and the casting channel stays flush to the level of concrete. Easy visual inspection is possible. You can easily know if the casting channel is installed properly or no, because the casting channel ideally should be flush to the surface of concrete, which is very easy to inspect via your eyes. And then product information. This is the Fischer portfolio of casting channel. To begin with, we have sizes starting from 29/20 all the way till 52 by 34 to cover all of your applications. So I believe we have a complete range to match any requirement which you might have. So we also have an assortment of eye anchors. So eye anchors are, if you notice the difference, here you have anchors welded to the channel, and here you have an I-beam welded to the channel. Of course, the reason you might have imagined, it is due to heavier loads. And then we have an assortment in the cold formed portfolio as well. So you have a similar range of sizes to match your requirements to optimize. And then how do we call our channel Castin channels? The nomenclature is pretty straightforward. FES stands for Fischer Einlegeschiene. This is a German translation for Fischer Casting channel. And then we have H or C here, which is for hot rolled or cold formed. And then you have letter S. If letter S is present, it means that the channel is serrated, or the channel from the inside has got teeth to grip, and this allows for third degree of loading. And then I, if it is present, denotes the I anchor. The channel doesn't have normal anchors, but it has I beams welded to it. Now the numbers, 52 stands for width, 34 stands for height, and then we have the length. For example, if it is 52/34 450, means the length of the channel would be 450. And then the coating available on the channel, by default all our Castin channel comes with hot dip galvanizing, a minimum thickness of 50 microns. And in brackets you have dash RI or RO. This stands for the radius. It could be inward or outward. Again, this is not mandatory on every channel, but only you would see this in curved channels. So if you are working on tunnels or any curved building structures, then you would have a requirement for curved channels. So then you would have the radius also mentioned along the product name. Yes. So there are also three types of bolts available. Before I specify the three types, I would like to show again the method of fixing of T-bolts. So you can see the Castin channel is normally embedded inside concrete, and then you use a T-bolt, twist it, and then tighten these nut to your base plate. So as you can see, it locks exactly at the location. Okay, now for the T-bolt assortment, we have different range. For the T-bolts, we have different range available, which we would see in a minute. So the option one is the standard T-bolt, what you can see with me. And then the second option is a notch T-bolt. The notch T-bolt has got a specific embossment on it. So when you tighten the nut on the notch T-bolt, it pushes hard into the casting channel and creates a female notch on the channel. This is used again as an option when you have higher loads and you require a third degree of loading. So as an example, when you have a seismic load, so you have wind load and dead load in the common directions, whereas you might have seismic in the third direction of loading. And then we have serrated channel bolt on our smaller hot roll channels. So this is also the channel will have serrations, as well as the channel bolt would also have serrations. So it rests inside the female serrations of the channel and it locks inside. So this also allows for third degree of loading. So basically we have two channel bolts option for third degree of loading: notched for the bigger size of channels and serrated for the smaller size of channels. So nomenclature for T-bolt is also very simple. FBC stands for Fischer bolt channel, N stands for notch, or S stands for serration. 50 by 30 means it fits channels, what size of channel it fits. And then M stands for metric, D stands for diameter, and then multiply with the length of channel bolt which you require. And then the steel grade is normally 8.8, and then hot dip galvanizing. I would like to show some reference list of reference pictures from some of our projects in Dubai. So this was an installation where the channels were installed at the bottom of the slab. So here you can see we don't just sell products, we go to the site, inspect the scenario, give a solution, propose the products, and then finally we also assist your team in installation to make sure that all products are installed in the right manner. You can see here the channels are connected to the plywoods, which is the temporary formwork, and also connected to the reinforcement bars. So this is a much closer picture. You can see the channel just linked to the reinforcement bars to prevent it from moving while you pour concrete, and after concrete is cured, this stays there in place throughout the lifetime of the building. So there are different codes in design of Castin channels. So the most common code what we use is the EN 1992 Part 4 2018 for design of fastening in concrete. We also use EOTA TR 47, which is a calculation method for performance of anchor channels. And also we combine with our years and decades of experience in the fixing business. So we have a very strong engineering team who can work with any complex solutions. The products are all assortments of satisfying the ETA assessment criteria and also the fire reports. Also, last but not least, having a product is not just enough. We also have a beautiful design software capable enough to model most of the cases. You might have seen in the video how easily you can change the parameters, you can change the length and width of the channels and so on. So we have different arrangements possible. So if you are already user of the Fischer Fixperience suite, you might already have seen the Fischer channel fix icon appearing in it. If no, please update your software and you would get the channel fix as part of your Fixperience suite. So this is how the calculation looks like. You might have seen this arrangement familiar because we follow the same calculation method, the calculation display in channel fix similar to the cfix or the anchor design software. So the advantage is you can see all the calculations using formulas step by step to make yourself more easy, and you can also learn from this calculation report because everything is black and white. So the design of all available channel sizes and length are available. We are designing based on the EN code. We have a technical team locally as well as internationally to answer and support you with any of your concerns. We can also do testing at site. We can do design support to choose the most optimal and economical solutions for your problems. And then comes our favorite topic, anchors. So also for facade, I would say there are millions of anchors being used every day to fix facade elements to building structures. So to begin with, we would show the most popular anchor used in the facade industry called FAZ2.
Fischer Faz2, the power anchor for highest
The
demands.
technical team would play the video at the moment.
Applications in concrete, the perfect solution in cracked and non-cracked concrete. In addition to the use of standard drills, the new ETA assessment document also covers the use of hollow drills and diamond drills. The FAZ2 is suitable for pre-positioned push-through and standoff installations for the most flexible usage. The tried and trusted expansion clip ensures stability and highest load-bearing capacities. The new cap nut gives the option for a more aesthetic finish. The shorter bolt makes considerably shorter drill hole depths possible for a significantly faster installation. The variable embedment depths enable the most accurate adaptation of the loads, flexible, efficient, time-saving. New, an extended range of application with experts report for use in concrete C12, 15 and C80, 95. Brand new, the FAZ2 M6, the first bolt anchor worldwide with drill hole diameter 6 mm and ETA option 1. Maximum load with maximum embedment depth for the FAZ2 with diameter 10. The perfect solution for fixings of railings, facade, substructures, tension anchors in timber construction, pipe routes, cable trays and much more. The Fischer Faz2. This is how versatile power can be.
Okay, that was pretty clear, I believe. That was the FAZ2, the most popular anchor used for facade installations throughout the world. I don't have to explain further about this product. The second product is Fischer concrete screw. It is called the FPS Fischer bolt screw, and this also have a lot of features such as seismic approval, crack concrete approval, fire rating, to name a very few. It also comes with different head versions. I would like to talk less and go straight away to the video.
Fischer Ultracut FBS2, the high-performance concrete screw for absolute installation needs. Zinc-plated steel with a diameter of 8240 in A4, and for the sanitary, heating and electrical industry, out of zinc-plated steel with a diameter of 6 mm. With unique screw geometry for simple and effortless installation. Cleaning the drill hole is not required when using hollow drills or vertical installation in ceilings and floors. The unique sawtooth geometry enables fast cutting into the concrete. The special thread geometry cuts deep into the concrete, offering heavy load capabilities. Therefore, less anchoring points and smaller base plates are required. Efficient and time-saving. The Ultracut FBS2 can be unscrewed twice for a total length of 20 mm and place maximum 10 mm packing below the base plate, enabling the fixture to be adjusted exactly. Ultracut FBS2 in zinc-plated steel with a diameter of 8-14. Secure and flexible in cracked and non-cracked concrete, even in earthquake zones. Visually appealing with countersunk head or as a hexagonal head, with and without internal Torx drive. The checking gauge allows the outer diameter of the thread to be checked. Therefore, it is approved to be reused in the zinc-plated steel version. Versatile and efficient. The short version with a reduced drill hole and screw in depth. Ultracut FBS2 zinc-plated steel. Perfect for railings and balustrades, shelving systems, brackets, step or beam anchorages. Ultracut FBS2 A4, made of corrosion-resistant stainless steel. The ideal fixing solution for use in outdoor areas and for wet conditions. The specially hardened red tip provides a faster and more secure installation. For the highest demands, the A4 version is particularly suitable for metal construction and applications in outdoor areas. For example, railings, consoles, canopies, stadium seating and even more. Ultracut FBS2 zinc-plated steel with diameter 6. 5 head designs cover a wide range of installation possibilities. For functional and visually appealing anchoring. It offers maximum flexibility for sanitary and heating applications. Fischer Ultracut FBS2, the high-performance concrete screw for absolute installation needs.
Hi, welcome back. I can see that there was some technical issue with the sound. Do not worry, we'll share the link for these videos shortly in the chat screen, so you would be able to see this via YouTube. So my technical team would shortly be sharing the 2 links for these 2 videos. Coming back, we have few more products to show some possible popular alternatives in facade installation. Another favorite among the facade segment is the SXRL. It is a nylon plug with screw. It comes with 2 head versions, a countersunk option for railings or balustrade installations, as well as fixings in masonry. And then we have a hex head version, also suitable for heavy installations such as lower installations or steel element installations. So the main advantage of this product is it is ETA approved for use in multiple base materials. It has been tested for more than 40 different base materials. It has got a fire rating, and it is also approved for use in cracked and non-cracked concrete as well. So it is an absolute all-rounder. It could be used in any base material you have at site. So this is again a problem solver. Mostly used for facade elements as temporary lightweight restraints in blockwork supports. It works in weaker materials such as AAC blocks or hollow blocks as well. And then we also have another all-rounder, but this all-rounder is little more heavy duty. It is called the FISB, Fischer Injection System Windlaster Motor, and this is approved for again different multiple base materials, and it is used for structural as well as fixings in masonry. It is also approved for seismic. It has got ICC approval, which enables it to be designed as per ACI 318, and also it can be used in fire designs. So it is versatile, and absolute problem solver. When you have any base materials, you can use it with utmost ease. So this particular chemical, it comes with different a huge portfolio of accessories. So why do we need a lot of accessories? For example, when you have an AAC block, autoclaved aerated block, or the white color lightweight block, you have flexibility to use a normal drill hole, as you can see, or you can use a little more heavy duty conical drill hole, which is made possible using two elements, the centering sleeve and the special drill bit produced by Fischer, which enables you to get higher loads, and this is as high as you can get from AAC block. So we have tested and we have got up to 7 kilonewtons on such blocks. Again, depends on the strength of the block and the installation depth, but yes, this is as high as you can get from AAC block. And then these are some pictures of the chemical installed in hollow elements, hollow blocks. So here, as you can see, we use a special sleeve, a nylon sleeve, and then the chemical is injected, and the rod is inserted, and it locks from behind. So it forms a grip from behind by locking principle, so the anchor stays intact, and it gives you the desired loads. So those are the anchors which we thought, or based on our sales history, are the most popular in facade business. Now I am open to answer all your questions. Again, as I can see, we have a lot of participants from a lot of countries. So please note that we are available in most of the countries in Middle East and in Europe. So wherever you are, feel free to contact your local Fischer representative. Please post your questions in the questions tab. And now we have some time, like around 10 minutes left for the question and answers and interaction. If you have any questions after this event, please feel free to contact me on this email address mentioned. I'd be happy to assist you with all your concerns. Let's jump back to the questions. And just to add, we have shared the video. I hope you are able to see the video clearly now. If you have any problems, please do let us know. Okay, let us go to the questions. Okay, the first question is from Mr. Prakash. Can I get a copy of the video? Yeah, so we have already shared the anchor videos. This Castin channel video is relatively new, so definitely we will shortly share the video also to you. Not a problem. It would we are just waiting for it to be uploaded in YouTube, and then we can share you directly the link. Varun has a question: can a Castin channel used in hollow blocks? No, unfortunately, these elements, Castin elements, are designed to work only in concrete. So Castin channels, you have to go to one of our anchor solutions, which works perfectly fine in hollow blocks. What is the size of anchor as slab or wall thickness varies? Great question, Prakash. Yes, we know that you have different wall thickness of slab and wall. So to match your requirement, also to cater to the loads, just like anchors, the Castin channel also comes with different embedment depth. So you can choose the appropriate anchor which is working in a shallow base material if you have. So the smaller sizes like 29/20, it comes with lesser embedment depth compared to a 52 by 33 channel. Mustafa had asked a beautiful question. What do you mean by third degree of loading? So basically, when we talk about Castin channel, you have a load which is acting uh, perpendicular to the channel, which is a shear load, and then you have an load which is acting parallel to the channel, which is tension. You might also have another load which is acting along the length of the channel itself. For example, let me show. I hope my video is still clear. So this is a Castin channel. So you have loads in this direction pulling the Castin channel outside concrete. That is tension. And then you have shear in this direction or in this direction. So that is the second direction. And then you might have also load acting along the length of the channel in this direction. So the load is moving, trying to move the channel in this direction. That is the third loading direction. So if you have a third loading direction, you should preferably use a serrated channel or a notched T-bolt. I hope, Mustafa, I was able to answer your question. Norman have asked a question. How do you determine the required torque for each anchor? So, Norman, to make your life easier, each anchor is predefined with the correct torque which you need to install it. So it comes when you buy any product from Fischer. We have the predefined torque values. You just need to tighten it. It is done based on engineering study and test by Fischer itself. Suraj have a question. Can we get the software for anchor choosing, and also can we get a training for the usage of this software? Yes, Mr. Suraj, this is good. It is very important that you start designing. You would also become useful with the software. I understand that you don't have the standard experience version of for anchors as well. So definitely someone from Fisher will contact you shortly, and then we would plan a training for your team. Thank you. Mohammad Riyad has a question. I believe there is edge distance issue in casting channel compared to chemical anchor bolt. Can you explain about edge distance of each anchor? Okay, this is a brilliant question, Riyad. As you might have known, that just like chemical anchor or mechanical anchor, any anchor, the casting channel is also having anchor component. So when you transfer the load, of course, we have to take care of the edge distance. Now, when we talk about edge distance, it is not a predefined edge distance which we mentioned, but it is varying. For example, if you have narrow edge distance, you would get slightly lower loads compared to you don't have any edge distance at all. So I would my recommendation would be to check your real scenario in the software, because the software analyzes the concrete location and geometry, and then it would tell if the loads applied is safe or no. Rather than giving, we don't have a thumb rule as such, because you have a lot of parameters to affect the edge distance. We can give you the minimum edge distance for each anchor. This is purely from installation point of view, but it will not give you an indication on how much load you can do while you optimize your edge distance. So it is always better to go back to the software, and then the software calculates all the hard work for you. Shobi has a question. Do you have stainless steel casting? Uh, Great question, Shobi. At the moment, we have only hot dip galvanized casting channels. If you have a requirement for stainless steel casting channels, please do let us know, because we are also working on development of our future products. So if you have a good requirement, please do let us know. We can see what is possible and how we can support you with your requirement. Adrian, nicely presented. Thank you very much. But you would need to point out what can go wrong during the installation of casting system and how to get off the problem with other Fisher products. Okay, this is again a vast topic, Adrian. Thank you for highlighting it. Yes, this is the reason why we need your feedback. So definitely next time when we present, we would go more deep. This we planned as a level one where we discuss only the basics. But yes, this is another topic for another session. So definitely we would plan something which involve problem solving and on-site issues of Castin channels and interaction between anchors. Definitely we would plan something in the near future. What is your opinion on the requirement for proof test on site? Are the requirements the same as for post drilled anchors? See, actually, Stefan, to be honest, these Castin channels are installed and they are approved by the European Technical Authority. So, proof load as such is not required because all the loads which the channel can take is directly defined based on the grade of concrete and the channel section which you use. So, in my opinion, proof load uh, are not required. Even for anchors with ETA approval, my recommendation would be not to do any proof load tests unless you have a doubt on the quality of installation, which is the same in Castin channel as well. We can definitely support you with some testing at site to prove that the installation is matching your requirement if it is required. But definitely testing at site, we can do it. But as a standard, no, we don't recommend. And we have done projects and we have not done pull out test for Castin channels. I think we have reached at the end of the online seminar. I would again request you all to please visit the polls tab and rate this webinar. Give us your polls. Please, some of you already gave me your feedback in the chats, but please give us in polls so we record it and then we can use it for improving our services. We have one last question. Suraj is asking for chemical curing. How long does it take? Excellent question, Suraj. I don't have an answer just like that because we have a huge range of chemical anchors. So we have fast curing chemicals uh, starting from 5 minutes. You can apply the load, or we have uh, chemicals which can cure in 30 minutes, or we have chemicals which can cure in 5 hours. For example, the chemical which I showed in the presentation, it is called FISB. In Middle East climate, in summertime, you can apply the load in 30 minutes. So that is to give an idea. The chemical curing again depends on the service temperature of concrete. So if you have summer, your chemical cures really fast, whereas if you have winter, you have chemical curing relatively slow. So do not worry. Any chemical which you buy, on the body of the chemical, you would see a label where the curing time is mentioned. So just follow that, and that's it. Fixing an inverter box on hollow block wall. Yeah, excellent question, Mr. Yatindra. So we have to see what is the weight of the inverter box and how many anchors you are having. Do you require additional channels and so on? But please, we would get back to you and we would try to find out more of your requirement, and definitely we can provide a right solution. If you don't have a much heavier application, you can even go with nylon product what I showed. If you have heavier loads, then possible option would be chemical anchor with sleeve. So it purely depends on the loads and the arrangement. So we would definitely check it out and get back to you. Mm. Someone had asked a question that you want to see a Castin channel. I think it was by Mr. Deep Shika. So if you are still available, please would you mind typing on the chat? Okay, no problem. We would definitely share the WhatsApp details. This would be my WhatsApp number. You can also send me your concerns. Okay, I hope we have reached at the end of the online webinar. I had fun. I enjoyed doing this webinar because it was always interactive. You were asking a lot of questions, replying to my questions. So it was really fun. So thank you very much for your participation. I hope I was able to add some value addition for you today. So please stay in touch, and please, if you require any technical support, get back to me or my colleagues, and we would be more than happy to support you with all your applications in your construction site. Thank you very much.